This is video on statics of concurrent planar forces. We are solving equilibrium problems and we are looking at the problems which involve spheres and cylinders, and this is second video on spheres and cylinders. So there is one more video on this type of problems which also you might want to see. In the overall study plan, we are at statics of concurrent forces which are in equilibrium, and we are looking at this particular type of cylinder and sphere type of problems. See, there is no limit to number of problems, so as much as possible we group the problems to make our life a little easy. So the steps are very standard, these three, for any of these type of problems. That is, draw free body, settle geometry, that is, find angle of inclination of all the inclined forces, that's what I mean by settle geometry, and then write your equilibrium equation, that is sigma fx and sigma fy 0. And while doing this, these points have to be remembered while drawing the free bodies. That tension force is always away from body, reaction is always towards the body, sphere, cylinder touch each other, and any wall or roof or ground, they touch at only one point and the contact is tangential. And lastly, if three forces keep the body in equilibrium, then these three forces are necessarily concurrent. Okay, with this background, let's read the problem. Three similar tubes of weight 8 kilonewtons are placed as shown in figure. Determine the forces exerted by the tubes on the smooth walls and floors. See, here are the tubes with given geometry, and if you draw the free body, these are the forces. What is asked is what reactions are coming out of wall and floor. That is, essentially we need to find RA and RC. We need to find RA and RC. No, sorry, RC is between them, but we need to find RA and RB. Yeah, because they are asked reactions from the floor and the wall. Okay, it's sufficient for this particular type of problem to solve only two tubes, that is the top one and the left one, because the right one is similar to left one. So we are going to do that. Now our steps are, as many bodies, those many free bodies you draw. So if you see the top body, we have drawn the free body, the weight and the reactions coming out of two tangential contacts with the other tubes, and the lower cylinder also we have drawn the free body, where the weight is there, it touches at A, so RA has come out, it touches at B, so RB has come out, and then it touches like there is a contact between two tubes, so RC has come out. Okay. Now, having drawn the free body, and see geometry is settled because 30 degrees given. For each cylinder, we are going to write sigma fx and sigma fy equal to 0. So if I write for cylinder 1 sigma fx equal to 0, what I get is RC cos 30 minus RC1 cos 30 is 0. So I come to know that RC is equal to RC1. Then I write sigma fy equal to 0. I get RC sin 30 plus RC1 sin 30 minus 8 is 0. But RC is equal to RC1. So 2 RC sin 30 is 8, and therefore I get RC as 8. So for cylinder 1 gives me this information. Now cylinder 2, again I write sigma fx0, sigma fy0. Sigma fx0 tells me minus RC cos 30 plus RA equal to 0. That gives me RA. And sigma fy equal to 0 tells me minus RC sin 30 plus RB minus 8 is equal to 0. That gives me RB. So R and RB were essentially asked. So those are found on the right side. And the reactions are same because of the symmetry of the problem. Let's look at one more problem. Here are three cylinders are piled up in a rectangular channel as shown in figure, and we are required to find reactions at contact points. Okay, and the data for cylinders are given. ABC cylinder, the radii and the masses are given. The radii and the masses are given. Okay. Now see. Our methodology will be for each cylinder, we are going to draw all the forces, that is free body, and then we are going to settle geometry, and then for each cylinder we are going to write sigma fx0, sigma fy0. See now. First we are chosen to settle geometry. So see, you see these two triangles. Now let's take the top triangle. You see the hypotenuse is 11, because see the radius of cylinder C is 5, radius of cylinder B is 6 and 5 11, and the base is 18 minus 5 minus 6. So 18 minus 11, that is 7. And once we have this base and hypotenuse, we can find that angle as 50.5 degree. Now see the bottom triangle. The hypotenuse is 10 because it's cylinder A's radius plus cylinder B's radius. And the base of this triangle is 8, which comes from 18 minus 4 minus 6. That is 18 minus 10, 8. So therefore the line joining centers of the lower cylinder is inclined with horizontal at 36.87. Upper cylinder it is inclined at 50.5 degree. Okay, this geometry settling will be required as we proceed. Now we draw free body of top cylinder. The weight is 200 Newton. From R1 reaction comes from the contact point 1 reaction comes R1, and then at point 2 it touches cylinder B. So from there the reaction what comes out is R2. Similarly, we draw free body of B, the weight, the R2, R3, and see it touches lower cylinder at 4, so R4 comes out. You have to know that R4 has to be along the line joining the radius. R2 has to be also along line joining the radius of B and C. R4 is along the line joining the radius of line joining the centers of A and B. Now the reason is these contacts are tangential, so the reaction direction has to be normal to the tangent, and therefore they have to be along radius. And because there are two cylinders involved, they can be for both the radius only if they are along the line joining the center. Okay, so for the cylinder A also we have drawn 150, then R4, R5 is coming out from bottom, R6 is coming out from the left end. So now we are ready. See, we have the free body, we have the geometry. So we take cylinder C, write sigma fx equal to 0, sigma fy equal to 0. Sigma fx equal to 0 tells us R1 minus R2 cos 50.8, 50.48 equal to 0. So you get R1 as R2 cos 50.48. Sigma fy is R2 sin 50.48 minus 200. That is R2 sin 50.48 is equal to 200. You can solve for R2 and R1 and you can keep it aside. Go to cylinder B now. Do the same thing. Sigma fx0, sigma fy0. Sigma fx gives you R4 cos 36.87 minus R3 plus R2 cos 50.5. Then sigma Fy equal to 0 gives you R4 sin 36.87 minus 400 minus R2 sin 50.5. And then from these two we can come up with R4 and R3 and keep it handy. Then you go to last cylinder last cylinder A. Do sigma Fx 0, sigma Fy 0. You find that sigma Fx is equal to R6 minus R4 cos 36.87 equal to 0. So R6 is R4 cos 36.87. So R6 is 800. Sigma Fy you solve. It's R5 minus R4 sin 36.87 minus 150. That is equal to 0. You get R5. And thus you get all the reactions R1, R2, R3, R4, R5, R6. And that's what was asked. Thank you.